Welcome to The Explainer. I am so thrilled to have you here today because we're diving into something that literally affects the daily lives of millions of people and is rapidly reshaping our global infrastructure right before our eyes. We're mapping out the incredible evolution of electric vehicle charging. We're going to go on a pretty fascinating journey today. We'll start right at the ground level, looking at how to fix the absolute most basic, hair-pulling frustrations of passenger car charging, and then we're going to scale all the way up to the massive, mind-bending horizons of heavy-duty electric transport. Let's jump right in.
Okay, let's dive into this, because if you drive an EV, you absolutely know this universally understood frustration. You're running low on battery, your app tells you there's an available charger right around the corner, you pull up, plug in, and literally nothing happens. It's completely dead. It's the kind of moment that makes you want to just throw your phone straight out the window. And looking at the data, this isn't just bad luck. It's actually a systemic issue. So why exactly do roughly 1 in 5 of all EV charging visits fail? And more importantly, how is the industry actually fixing it?
To really understand that failure rate, we've got to look at what researchers over at Stanford University are calling the zombie charger phenomenon. Consumer intelligence data from J.D. Power over recent years shows a pretty staggering reality. 19 to 24% of EV drivers experience charging failures. That means basically a quarter of the time someone tries to refuel their vehicle, they just can't. The main culprit here? Chargers that are simply out of service or inoperable. But here is the really tricky part. A lot of these are deceptive zombie chargers. They look perfectly fine and they say they're online to the network and on your mobile app, but when you actually get there, they physically cannot dispense any power. And as the Stanford researchers point out, these deceptive zombies hide perfectly within standard annual performance reports.
So, here's our roadmap for the explainer today. 1. The EV charging problem. 2. Fixing zombie chargers. 3. The market is stabilizing. 4. The heavy-duty horizon. And 5. Powering the future.
Part 1. The EV charging problem. Diagnosing the issue.
You know, as any good engineer or mechanic will tell you, you absolutely cannot fix a problem without first accurately diagnosing it. Right now, nearly 89% of the roughly 78,000 public U.S. charging sites are connected to a broader network. But the issue here is that local operators rely entirely on this overarching network to tell them if a charger is actually working. So, if there is a communication glitch between the physical charger and the network, that local operator is totally blind to it. Connectivity issues are a massive blind spot, and it leads straight to those zombie chargers we were just talking about.
Part 2. Fixing zombie chargers. Actionable metrics.
Now, what's really interesting about this slide is how it breaks down our metrics. Traditionally, the government relies on this really simplistic, kind of delayed metric called NEVI uptime. It basically just asks if a charger was generally available over the last year. But it doesn't actually tell a site operator why a charger failed. The Stanford researchers, though, propose something much more actionable. Things like fault time to track specific internal errors, fault reason time to tell mechanics exactly what part to fix, and crucially, unreachable time. This flags when a charger has lost network connectivity, which is exactly our zombie charger state. Having this granular data empowers operators to actually fix hardware and network bugs instead of just guessing in the dark.
And this brilliantly illustrates exactly what we're talking about. When you take the data from a standard charging site over a few years and decompose it using these new metrics, all that hidden instability is finally revealed. Those moments of fault time and unreachable time show us exactly when the chargers go rogue. By separating out these specific states, we uncover the exact network drops and hardware faults that are plaguing EV drivers. It makes it totally possible to target maintenance right where it's needed most.
Part 3. The market is stabilizing. A maturing industry.
Let's look at how this builds into the broader picture right now. According to fresh industry data from the first quarter of 2026, fast charger reliability across most U.S. states is actually hitting the 90 to 95% range. That is a massive, highly tangible improvement from roughly 85% just a year prior. It proves that older equipment is finally being upgraded, newer sites are using better metrics, and operators are genuinely getting a handle on running these networks day in and day out.
Meanwhile, the average utilization is holding perfectly steady at 15.6%. But what's truly incredible here is that the industry added about 3,300 brand new fast charging ports in that single quarter. This means the market is absorbing all that new supply flawlessly without overbuilding. It's smart, controlled, and totally sustainable growth.
And honestly, the quality of that growth is just impressive. 67% of all new ports installed in Q1 of 2026 are rated at 250 kilowatts or more. We aren't just building more chargers anymore, we're building ultra-fast chargers.
High-power charging is absolutely no longer a premium luxury tier for a select few vehicles. It is now the absolute baseline for the industry. And with the passenger network stabilizing like this, the infrastructure is finally robust enough to tackle the final boss of electrification: zero-emission commercial trucking.
Part 4. The heavy-duty horizon. Zero-emission trucking.
Because to power a massive semi-truck, a standard 250 kilowatt fast charger just is not going to cut it. You need the Megawatt Charging System, or MCS. This is literally next-generation technology capable of delivering up to 1,440 kilowatts. To put that into perspective for a second, that is nearly 6 times more powerful than the absolute fastest passenger car chargers we just talked about. This mind-blowing scale of energy transfer is exactly what's required to allow long-haul electric trucks to fully recharge their massive batteries in just 30 to 45 minutes, meaning drivers can easily recharge right during their legally mandated rest break.
And this isn't just a fun concept, it is happening right now, spearheaded by a joint venture in Europe called Millance. In 2023, they opened their very first hub. By 2024, they were successfully testing this megawatt system. Then, in 2025, backed by over 111 million euros in EU funding, they launched that 1,440 kilowatt beast at the port of Antwerp-Bruges, which basically kicked off Europe's first ever MCS corridor. And looking ahead to the end of 2026, their goal is to have 50 operational charging hubs spanning 10 different European markets. The zero-emission freight transition is moving at lightning speed.
Part 5. Powering the future. Local human benefits.
Let's transition from European highways and bring this down to a local, tangible level. Take New York City. Waste Connections, which is a major solid waste provider, has successfully deployed fully electric Peterbilt 520 EV garbage trucks right into the heart of the city. Just think about how heavy and power-intensive a garbage truck is. You've got the constant stopping, starting, and running those massive hydraulics for compacting. Yet this electric behemoth has the capacity to service up to 1,100 containers on a single battery charge. These massive sanitation vehicles are running heavy-duty commercial routes entirely on battery power.
So the crucial point is, the impact here goes way beyond just reducing diesel emissions. As Anthony Hasri, their district manager, points out, the introduction of this electric truck significantly reduces noise pollution. In a super dense place like New York City, commercial waste collection happens late at night. So eliminating the deafening roar and the heavy rumble of a diesel garbage truck completely transforms the nighttime environment for millions of residents. It's a real game changer.
But what makes this New York example even more compelling is the complete clean energy loop they're building. These electric garbage trucks are charged up at a facility in the Bronx. And how are they powering those heavy-duty chargers? With newly installed solar panels right there on site. They are literally capturing the sun's energy, using it to power their massive garbage trucks, and they're even converting their lighter fleet of gas pickup trucks to electric Ford F-150 Lightnings, the whole shebang. It creates a genuinely sustainable municipal system that attacks both carbon emissions and noise pollution at the exact same time.
We've gone from diagnosing frustrating little software glitches at local charging stations all the way to witnessing the birth of megawatt highways and silent solar-powered garbage trucks. And it leaves us with a really provocative final thought to chew on. We know passenger EVs are making a serious dent, but what happens to global emissions and the actual air we breathe in our cities when the biggest, heaviest polluters on the road are finally plugged in? The infrastructure is arriving, the market is stabilizing, and the heavy-duty horizon is officially here. Thanks so much for joining me on this explainer today, and definitely keep your eyes on the road ahead.